Okay, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain to you the calculation of enthalpy of reaction based on the energy cycle method. Now, when do we use the energy cycle method? For example, certain chemical reactions do not occur under standard conditions. What is standard conditions? That means at 25 degrees Celsius and 1 atmosphere. In other words, some of the chemical reactions occur at temperatures higher than 25 degrees Celsius, much higher, and can be quite difficult to actually carry out the reactions within laboratory circumstances, within laboratory settings. So because they cannot be measured directly, we have to calculate the enthalpy of the particular reactions based on the enthalpy changes of reaction that can be measured or can be determined experimentally using the energy cycle diagram. For example, in this slide here, we can use the enthalpy of combustion data to calculate the enthalpy of formation of a compound. Yeah. So now, looking at the diagram here, you can see this is a cycle. Yeah, it's a cycle. Now, where do we start? So you have to identify basically the starting point, or the starting energy level, or the starting the state, yeah, of that particular system. It starts here, right? And then first reaction with its own enthalpy change of reaction, and then from here another reaction with its own enthalpy of reaction that produce the particular products. Now, so this is two steps, step 1 and step 2. Now, another possibility is from this particular reactor is converted into the products. Only one step. So therefore, based on Hess's law, the enthalpy change of this step here, HC2 or enthalpy conversion 2, is equivalent to the sum total of this enthalpy change plus this enthalpy change. So this is an energy cycle diagram. So now basically there are certain points that you have to remember before constructing or drawing the energy cycle diagram are for example, if you are given the combustion data, so what you have to do first, start with an equation to represent the energy change. So whatever data that you're given, be it enthalpy change of formation or enthalpy of combustion, you have to write down the equation, the correct equation. So using the combustion data, complete the Hess's law. So you must make sure they end up in the cycle. So balance the cycle and add symbols representing enthalpy, delta H1, delta H2 and delta H3. Remember to get the direction of change correct. Okay, that means if you prefer the reverse reaction, make sure you change the sign correctly. Yeah, if so, basically if the forward reaction is exothermic, the reverse of that reaction will be endothermic. Yeah. And then basically once we've done that, use Hess's law to find the relationship between the enthalpy changes and rearrange to find the value wanted. So as an example for you to do, here I've given you the diagram, or the energy cycle. Here it is the formation, yeah, and enthalpy of formation of methane. Yeah, let's say you want to find this enthalpy change of formation of methane. For example, let's say you want to find out enthalpy of combustion methane. Let's say this data is given. Yeah, the combustion data is given. For example, methane. So methane, when it is being burned, you will get carbon dioxide and water, right? So carbon plus hydrogen forms methane. Methane burns form carbon dioxide and water. Now carbon and hydrogen burn separately. You will also get carbon burn in oxygen, you get carbon dioxide. Hydrogen burn in oxygen, you get water. Now, so what are the data that you probably have to find out from your textbook or from your tutorial book or from the internet? Yeah, from what I see here in the diagram here, you have to find out the data. Let's say normally you should be able to find out the enthalpy for the combustion of carbon. Yeah, enthalpy change of combustion of carbon, and then enthalpy of combustion of hydrogen. Yeah, so you can find that out. So these two data you can find out, and you can also get the enthalpy of combustion of methane. Yeah, find those. If you can find these data, that means three data: enthalpy combustion of carbon, the enthalpy of combustion of hydrogen, and the enthalpy of combustion of methane. Yeah, if you have found this out, you should be able to calculate delta HF of methane. Yeah, please work it out and tell me the answer.